Welcome to Physics Made Easy channel. And your emphasis while you prepare any subject should be on the basics. If your basics are clear, then you can solve any problem. In most of the examination and in scientific research, once basics are clear, then and only then you will be able to apply the basics and make the applications or apply your knowledge. Now, in Young's double slit experiment, I am picking up some problems on YDSE, typical problems, and all these problems are not that tough once your basics are clear. I am again emphasizing the basics. In Young's double slit experiment, the intensity of light at a point on the screen where path difference is lambda is k. I have already told you, whenever you have to find out the phase difference corresponding to path difference, replace lambda by 2 pi. It means phase difference is 2 pi. And at that particular phase difference, the intensity of light is capital K. The intensity at a point where the path difference is lambda by 4. Again replace lambda by 2 pi. So we will get pi by 2. Now the mathematical relation is very much clear to us. First of all, we should be familiar with this formula that I is equal to I naught cos square phi by 2. Now in first case he talks about lambda, path difference lambda, and phase difference corresponding to this is 2 pi, and phi by 2 here is 2 pi divided by 2, and this is pi. And now replace phi by 2 by pi, and I will get I will write it here. I will get I is equal to I naught cos square pi. Now cos pi is minus 1. So this will be equal to I naught minus 1 square, that is I naught, and this has been given to be k. So now this implies that I naught is equal to k. Now I naught is given. Next what he says, the intensity at a point where the path difference is lambda by 4. Now again we have got path difference of lambda by 4. I want to calculate phase difference. Just replace lambda by 2 pi divided by 4. Now this comes out to be pi by 2. So this is phase difference corresponding to path difference lambda by 4. Now I shall be applying again I naught. I is equal to I naught cos square by phi by 2. I have just proved that I naught is equal to k. It means this is k. I have replaced I naught by k. Cos square phi by 2. Now cos square phi is pi by 2. Phi by 2 is pi by 4. So this is k. Cos pi by 2 is 1 by under root 2 square of this, and this is k by 2. This is equal to k by 2. Now the next problem I have picked up to prove the point of basics, the problem of JEE Advanced. People say that JEE Advanced is very tough competition, and for preparing JEE Advanced they tend to solve very difficult problems. You don't need to solve very difficult problems to understand the basics. Start from simple problem and keep on raising your level. And I think it's just the application of the basics which is more important. I am time and again emphasizing this fact because it is the most important point. A light source which emits two wavelengths, lambda 1 is equal to 400 nanometer and lambda 2 is equal to 600 nanometer, is used in Young's double slit experiment. It recorded fringe width of for lambda 1 and lambda 2, beta 1 and beta 2. Now the number of fringes for them within the distance y on one side is m1 and m2 on the other side respectively. Then which of the following is incorrect? Now here is the dice. In most of the situations we are habitual of finding correct answers or taking correct answer, but here is a pitfall which may uh, touch any even a serious student who is not enough presence of mind. He has asked incorrect answers and not the correct one. So from the very statement I concluded that here this is lambda 1 and this is lambda 2. Now from here I concluded that lambda 2 is greater than lambda 1. Now this beta, I will write it here. Beta is directly proportional to lambda. For sake of change, I will change the color because otherwise things may mix up. Now we are well familiar with the formula that beta is equal to, this is very basic formula of fringe width. So what I can see, this implies beta is directly proportional to lambda. Now, as what is given is this fact, lambda 2 greater than lambda 1. So we are given that lambda 2 is greater than lambda 1. Obviously, what will this imply? This will imply this thing, that beta 2 is greater than beta 1. So this is correct. This is correct but not the answer because he has asked incorrect answer. Now let us focus on the second part. We know that y is equal to lambda d by d for first maxima and m is the order of maxima. I can even write here ym, but I will just write y. So this fact is beta, means y is equal to m beta, or now y by beta is equal to m. So what he is saying, and the number of fringes for them within distance y, it means y is equal to constant, or y here has been kept constant. If y is constant, now y is given to be constant. Now if y is constant, what does this mean? M indirectly proportional to beta. Beta is directly proportional to lambda. It means m indirectly proportional to lambda. Now lambda 2 is greater than lambda 1. implies if beta 2 greater than beta 1, there is no doubt. As beta is inversely proportional to m, m is inversely proportional to beta, it means m1 is greater than m2. So it means this is also correct, but not the answer. Now, in the next part is angular separation. In the next part, what he has asked is angular separation. Now, angular separation is lambda by d. Theta is equal to lambda by d. This is angular separation. Theta is directly proportional to lambda. And lambda 2 is greater than lambda 1. This implies theta 2 is greater than theta 1. But what he has written, the angular separation of fringes for lambda 1 is greater than for lambda 2. It means this answer is incorrect. And this is what he is looking for, incorrect answer. So D is the right choice. Now this you can verify yourself that third maxima of lambda 2 overlaps with fifth minima of lambda 1. Find out the fifth minima and then find out the third maxima. And you will find that both of them are equal. Here, for this particular part, condition for maxima is n lambda into d by d. Now, n is given to be 3, lambda 600, and d by d is going to remain the same. So it means what we are looking for, we are just looking for n. No, but I will just solve it in a regular way. So this is multiplied by 600 into d by d. This is going to remain the same. So this is third maxima. Condition. This is third maxima, which comes out to be 1800 d by d. And here nanometer is the unit. In this case, condition for minima is 2n minus 1 by 2 into d by d into lambda. So lambda is 400. We don't want to change it. Now this is 2n. n is 5. 5 into 2, 10 minus 1, 9. 9 by 2. So I have got 9 by 2 into 400 into capital D by small d. Now, this is 200 and what I got is 1800 d by d. So third maxima 1800 d by d, fifth minima 1800 d by d. The third maxima of lambda 2 coincides with fifth minima of lambda 1. So in this problem, what we got is, now this problem was quite easy. So don't go by the fear psychosis that it is a JEE advanced problem. Now, another issue. Two coherent sources of intensity ratio beta interfere. Now find out this thing. First of all, we are given, I will again change the color. For every problem, I will change the color so that there shouldn't be any confusion about the light. So now, I1 by I2, I put it A and put this B. Squares of both, their ratios are two coherent sources of intensity ratio beta. So this ratio is given to be beta. Or what does this imply? Is A by B is equal to square root of beta. I will put it equation number 1. Now we know that I max is A plus B whole square. I min A minus B whole square. I max minus I min 4AB 10th grade formula. I max plus I min. This is again 10th grade formula. A square plus B square. If we add them, I will get this. If we subtract them, I will get this. Now, I max minus I min divided by I max plus I min. So this is 4 AB twice of A square plus B square. This cancels. So this comes out to be twice of AB divided by A square plus B square. Now divide both sides by B. Numerator and denominator. Divide numerator and denominator by B. So what I will get? 2 A divided by B whole of this A square divided by B square plus 1. From here I will get twice under root of beta. So this is beta plus 1. So in this way, even this problem was not that tough. Very simple steps, very simple problem. Now this problem is the famous the famous Bragg's law. You have to find out the phase difference. Path difference in this case. Condition for maxima is throughout these courses we have learned that condition for maxima is path difference should be equal to n lambda. In this case, let me first go through the problem. A beam with wavelength lambda falls on parallel reflecting planes with separation small d. The angle theta that the beam should make with the planes so that the beam reflected from successive planes may interfere constructively. We have to find out this angle. This is grazing angle and not the angle with the normal. Also note this difference. In reflection, we take angle with the normals. Even in refraction, basic principle is that we take angle of incidence and angle of reflection or refraction with the normal. Here, it is with the plane. In Bragg's law, this is the basic difference. From here, I will draw a perpendicular like this. From here, I will draw another perpendicular like this. This distance is given to be d. This angle is 90 degree. And now let me call it as A, or the diagram is already there. So we are taking feet of perpendicular here. This point has been taken to be A. Let this point is a whenever you have to find out the path difference, try to draw perpendiculars at appropriate places. This is M and this is N. Total path difference between the two rays is AMA plus AN. MA. Now this is a right angle triangle. I will write it as, let me write it as O. This point is O. OAM. In triangle OAM, MA is D sine theta. AN is again D sine theta. So this is 2D sine theta. If this is equal to n lambda, this gives us the condition for maxima. And now if theta is very small, then I can take 2D, or even if you don't take theta to be small, why should we take theta small? Let it be n lambda. From here we can calculate sine theta is n lambda by twice of D, and theta is sine inverse n lambda by 2D. Now if theta is very small, then you can remove this sine inverse. Again, the problem is not that tough as they are supposed to be. Now this is a very simple problem. But here is a pitfall. Pitfall is two slits each having width. Now width is given W1 by W2 is I1 by I2. So I will again change color with every next problem. So we will like to have different colors. So this is given. Now this W1 by W2 is 1 by 25, and this is I1 by I2 is 25 by 1. This implies I will write it as A square over B square is 25 by 1, because I intensity is directly proportional to square of amplitude. So from here A by B is 5 by 1, and now I max is simply I max divided by I min. Max is simply A plus B square, and min is simply A minus B square. Now this will be equal to A plus B square means 5 plus 1 square. A minus B square means 5 minus 1 square. This is 6. 6 means 36. Here I have got 4. 4 means 16. 4 and 9. 9 by 4. Very easy problem. Even some of the outstanding students, they did one mistake. They took W1 by W2 to be equal to A by B. Actually, it is A square by B square. Very easy problem, but a bit dicey. Now the next question again. You just need to know the basic formula of path difference and phase difference, nothing else in this question. So again I will go through a change in color. We have adopted it as a normal practice. Now D is given to be 5 lambda. Here this color is too light, I think, so we should change it. We can work with this color. D is given to be 5 lambda. Capital D is given to be 10D. Now, let me read the statement. The intensity at the maximum in Young's double slit experiment is I naught. First, this is I naught. Distance between two slits is this. Where lambda is the wavelength of the light used in the experiment, what will be the intensity in front of one of the slits on the screen placed at a distance of this D is equal to 10D. Now, first of all, I will like to find out path difference. Path difference is given by x into D by capital D. X into D by capital D. Now X is intensity placed at a distance of this. Distance between the two slits D is this, is 5 lambda. Now I will put all these values. So this will be equal to, first I have got lambda here. I will put all the values. Now X is given to be D by 2. X is given to be D by 2. From where did I calculate it? What will be the intensity in front of one of the slits on the screen? In front of one of the slits. Here I will have to revisit the diagram. Yes, this is D. This is one of the slits. In front of one of the slits means at E. If this is at E, it means, we'll have to locate that. Yeah. Now the purpose is served. Now, what does he say in the numerical? What will be the intensity in front of one of the slits on the screen? In front of one of the slits. Now, this is the slit. Either I have to find it at C, or if we choose B, then at F. C and F, both of them are at a distance D by 2. Both of them are at a distance D by 2. And I made use of this fact here. Now path difference BD is x small d by capital D. Fill the values. X is D by 2. This is D. And in denominator, this is 10D. This is 10D. This cancels with this. Now D is equal to 5 lambda. I will put value of D here. 20. This is 5 lambda. So this is lambda by 4. Lambda by 4 is the path difference. So phase difference will be just placed 2 pi in place of lambda. 2 pi means pi by 2. Now formula of intensity, I is I naught cos square phi by 2. If phi is pi by 2, then phi divided by 2 will be equal to pi by 4. I naught pi by 4 is 1 by under root 2 square I naught by 2. This is I. The intensity is I naught by 2. So this finishes today's lecture. What did I conclude in the end of this lecture? Focus on the basics. You don't need to go for very tough problems. Just focus on the basics. Apply them. The problems that I have solved today. Note it. JEE advanced problem. NEET AIP. It was AIPMT. And now this is again AIPMT. This is again NEET problem. So, whatever may be the level of examination, if basic facts and figures are clear, then everything will be taken care. So, before ending this lecture, I will request all of you to go through my videos carefully, and if you have some points of improvement to comment upon, then kindly tell me how can I improve. If you like it, then kindly share it so that the benefits can reach to the maximum possible people. With these words, I finish today's lecture with a promise that tomorrow I will come up with more MCQs and as well as theory part. So thank you very much for being with me for such a long time, and thanks from Physics Made Easy to all of you. Thank you very much.